let's use partial fractions decomposition to solve this integral. We're going to start off by factoring the bottom of our equation. So right now we've got x cubed plus 2x, but if we factor out an x from the bottom, then we'll be able to break this down with our partial fractions. We know that that x term, that's a linear term, so we just need a over x. And for the x squared plus 2, that's quadratic, so we'll need a linear term up top. Now we can multiply both sides of the equation by x times x squared plus 2, and that'll just clear out all of our fractions. If we expand out all of our terms, we'll get one big equation with a bunch of different terms in it. So one way we could solve this is if we split it up into the quadratic terms, the linear terms, and the constant terms. So for the quadratic terms, there's nothing on the left, and then we have a plus b on the right. For the linear, we have 2 in front of that x, and we just have c on the right. And then for the constant term, we got 1 on the left and 2a on the right. Then we can solve for a, b, and c. Once we've got all of those solved, we can go back to our original definition of our partial fractions, and we can go and plug in a, b, and c. Our integral still looks a little weird, so let's split this up into 3 separate fractions. I'm also just going to pull out the constants out front here, just to make it a little bit easier to see what kind of integrals we're going to use. So if we split those up into 3 separate terms, now we can just integrate each one of those. That 1 over x is going to turn into a ln. The x over x squared plus 2, if we use a u sub, we can turn that into a ln as well. And the last one will end up with an arctan.